Density is a measure of how much mass we have within a certain volume of space. So when we talk about something that's highly dense, we mean that it has a lot of mass crammed into a small volume. If we're talking about something that's really not dense, we're talking about big volumes with small mass. So when we're talking about solids and liquids, usually we're going to be using the units grams per milliliter. Hopefully that seems reasonable to you, that something that weighs about a gram is going to be measured on a scale, about the size of a sugar cube. 1 milliliter, 1 cubic centimeter. That's going to be typical for solids and liquids. For gases, however, gases are much less dense. They float on top of all these solids and liquids. When you go down to the beach, the gases are definitely floating above the water, and the bubbles float to the surface of the liquid as well. Now, for gases, the units are going to be grams per liter, so 1,000 times bigger volume in order to weigh the same amount. That's why gases are so light when we consider them. But that's not the right terminology. Remember, when we say something is light, we're talking about mass or weight. We're talking about density. We should be talking about grams per liter. Now, just remember that a milliliter is going to be a cubic centimeter. So it's going to be about the size of a sugar cube or a fishing sinker. And just to give you a scale for that, a dime is going to weigh about 2 grams. So if you take a dime and you melted it down, it would actually be much smaller than the cubic centimeter. You'd only fill it probably about a third to halfway up. So metals are going to be pretty dense. In fact, metals are all having densities of greater than 1 gram per milliliter. I think magnesium is the one that's the least dense, and even its density is something like 2 or 3 grams per milliliter. So all of our metals are going to be pretty dense comparatively. That's why fishing sinkers sink. Now, things that are less dense than whatever they're in are going to float. If you throw some styrofoam in the water, it floats. Well, mercury is really heavy and dense. Mercury, a little cube about like that, is going to weigh 13.5 grams for 1 milliliter. Now, that's just about twice as heavy, not quite, but almost twice as heavy as iron. So picture that. You're holding a chunk of iron about the size of a sugar cube. You grab a piece of mercury and it's going to be twice that weight. It's going to be really surprising when you pick that up. Now, if I were to drop the iron into the mercury, the iron is going to float, which is a weird kind of thing to think of, a metal floating in another metal. Now, the other funny thing that can happen right after that is the mercury could start to dissolve the iron, and we'll talk about that probably in Chem 2. But yeah, iron floats in mercury. Now, let me go for another movie example. Whenever you see a movie and somebody falls into the lava, you always see them slowly sinking, usually like, and catching on fire. Yes, that's my impression of falling in lava. They shouldn't do that. They should be floating. The density of the lava is going to be on the scale of the density of the rock. It's going to be pretty heavy per milliliter. You will be floating at the surface of it. Your foot might sink in just a little bit, but you are going to be floating in the sea of the lava. Just to prove it, let's look at the numbers. We know that we float in water, at least if we're not a witch. And 1 gram per milliliter is about the same density as water. We're about that. We're maybe just a little bit lighter, maybe just a little bit more dense. Notice I just used a sloppy word. We're not lighter, we're less dense. Or more dense, not lighter. So we're going to be right about the same density as water when we average it for the whole body. Now, lava is about 10 grams per milliliter. So yeah, we would float for a brief time until, of course, we suddenly combust into flames. Now, density is going to be one of our intensive properties. It doesn't matter how much of it you've got, the density isn't going to change from a small piece to a large piece. Density will stay the same.